So just like in the last section 8.1 with sine and cosine, to find equations from graphs for tangent, we also just kind of work backwards. We identify everything that we've talked about in the previous ones. Okay, we're going to identify the period is usually the easiest place to start. We'll also be looking at the asymptotes. Okay, stretching factor. We're going to be looking at vertical shift. This is helpful to find the middle of each piece. It's not a mathematical word, but it's helpful, I think. And then we're also going to be looking at, let's see, what are the big ones? Oh, for the stretching factor, it's actually helpful to look at the stretching factor. Kind of, oh, never mind, that's not the button. Let's look at the stretching factor after the vertical shift. Okay, it's usually a little bit more helpful. And that's going to be the point between the middle, so that's why we wanted to find the middle first, and the asymptote. All right, and then we're going to look for the phase shift kind of last. All right, and once we can do all that, well, the formula is A times tangent of bx minus c plus d. All right, so let's do this. Again, this is step 1, step 2, step 3, and step 4. You don't have to follow them exactly, but it can be a good order to go through them if you want. So what we're going to do, and I was going to prep this, but I forgot. So don't look, don't cheat, look away. Actually, I'm not even going to give you an opportunity. I'm not even going to give you an opportunity to cheat. We're going to hide it from you. Okay. So feel free to look. I'm going to give you a graph here, and you are going to tell me, well, metaphorically, what this graph, what equation this graph represents. All right, so here we are. We have this graph, and I'm going to zoom out a little bit, kind of like so. What is going on here? And let's zoom in on the y values real quick. Let's go -10 to +10 on these y values. All right, so actually, bigger y values kind of worked. We're going to look at a couple things here. Let's kind of follow the order here. Follow the order of what was kind of recommended. Let's first identify the period. And again, this is going to be example 3. Find an equation for, this is part A. We're going to first look at the period. Because again, right, y equals a tangent of bx minus c plus d. Let's first look at the period. How long does it take this function to repeat? Well, the middle looks to be about 0, 0. And then it repeats every 8 units. So the period is 8. But remember, b is not equal to the period. The period is pi divided by the absolute value of b. So 8 is the period, is pi over b. And we're not really gonna deal with many negative b's in this class. So we're just gonna look for positive b's. We can cross multiply, and that's gonna give us 8b equals pi, or b is pi over 8. Good. That's part of our answer. We now know our b value. All right. So We did step 1. Step 2, let's look at vertical shifts. Okay? Where is the middle, in a sense? And it's a little hard to see here, but it looks like the middle is just the x-axis. Okay? Notice that this does look like the middle of that piece. All right, it's functioning the same on the right as it on the left. So our middle, our step 2, our vertical shift, there isn't one. Okay? D is equal to 0. Step 3, let's look for the stretching factor. And for the stretching factor, we really want to look at the point between the middle and the asymptote. All right, so let's look for stretching factor next. So usually, in a regular tangent graph with no stretching, if we go halfway between the middle and the asymptote, we should move up 1 unit. Halfway between the middle and the asymptote is x equals 2. We should normally move up 1 unit. How many units are we moving up here? 2. Normally move up 1, but we're moving up 2 here. Similarly, if we go the other way, halfway to the other asymptote, we normally should move down 1, but now we're moving down by 2. So it's double from what we'd expect. So the stretching factor is 2. And remember, the stretching factor is not the same thing as A. This is the absolute value of A, and we do sometimes deal with negatives for our A's. But since everything is going up here, right, this is going up, we do know A is positive. Because it's always increasing. If it was decreasing everywhere, then A would be negative. Good. So we have B, we have D, we have A. We're almost done. Let's look at phase shift. So normally, the middle is at 0. The middle is normally when x equals 0. Have we been moved to the left or the right? No, because the middle of this tangent graph is also at 0. So there's no phase shift. And remember, phase shift is not the same thing as C. Phase shift is C divided by B. But again, multiply both sides by B. And you're going to get that C is equal to 0. So let's plug this all in and see whether we got the right answer. Y equals A, which is 2, times the tangent of B, which is pi over 8, times x minus C, which is 0, plus D, which is 0. This should be the graph that I graphed for all of you. And it turns out, as I unveil it, that it is. Okay. I'm going to give you another one now. One more problem for this video. I'm not going to read it out loud because that would spoil it. We don't want that. All right, so it's going to look like this. No, let's make it a little harder, actually. Make it a little harder. I hope I don't regret this. All right, let's look at this one. So hold on. I'm going to give you a slightly better scale to look at this at. Let's say this is going from something like this, like so. Yeah, let's do this, I think. So we have another tangent graph, and this one is just a lot more involved. So first off, right off the bat, the recommendations to look at the period, but right off the bat, notice that this graph is moved up. Okay? The middle of each piece looks like it's somewhere around here. I don't know where it is. Somewhere around here. We'll look at that later. All right? But just be aware that, yes, this graph has been moved up. let's follow the same order as was recommended over here. Step 1, let's look at the period. Okay, so the period is how long does this take until it repeats? And you can pick any point. So on Desmos, the x-intercept is useful. If you're looking at a graph from the book, the middle is useful. The asymptotes are also useful. There's a lot of ways that you can find the period. Okay, for example, our asymptotes are at negative pi over 2, 0, positive pi over 2. Our asymptotes are every pi over 2 here. Or you could find the distance between these. The distance between these is 4 pi over 8, which simplifies down to pi over 2 as well. Either way, the period is pi over 2. So b, and again, what are we looking at? Y equals a times the tangent of bx minus c plus d. The period is pi divided by b. So the period's pi over 2. That's pi divided by b. Let's cross multiply. We're going to get that pi times b is equal to pi times 2. Well, the pi's just cancel. You get that b is equal to 2. Great. We know the period, it's pi over 2, and we use that to find our b value. What does Jason recommend we do as step 2? Look for the vertical shift to find that middle. Okay, so the vertical shift according to our graph, what is that? Well, let's click on these points to make them go away. Where is the middle between 0 and pi over 2? It's pi over 4. These are negatives. Our middle is actually right here. All right, and it's a little hard to see. We're going to have to estimate a little bit. This looks like it's about halfway between 5 and 0. This middle is at 2.5. All right. So D is going to be positive 2.5. It'd be very helpful to plot this, but I don't want to plot it here because in the book problems that you're going to do on the homework, you're not going to be able to. Well, you could just draw on your book. I think you can draw on the OpenStax book. I think there's a feature for that, but I don't know off the top of my head. Anyway, this is our vertical shift. Good. And that helps us find the middle of each piece. Next, let's look at the stretching factor. October, don't you dare. October was causing troubles. October, tell them what the stretching factor is. It's the absolute value of A. She doesn't want to do math. Maybe you don't want to do math either. So let's look at the stretching factor. And that has to do, and again, stretching factor is the absolute value of A. And that has to do with a couple things. It says, if we start at this middle and go halfway to our asymptote, so halfway is going to be an x-coordinate here. Normally, we would go up 1. Normally, we would go up 1. Well, what are we actually doing? First off, we're going down. We're going down to 0. We started at y equals 2.5, and we're going down 0. So instead of going up 1, we went down 2.5. All right. We could do it to the left, right? If we go halfway to this asymptote, normally we'd go up 1 to 3.5, but when you go halfway to the next asymptote, we go up 2.5. All right, so it's negative, right? We're decreasing everywhere. Our A value has to be negative, and we're being stretched by 2.5. Okay, negative because it's going down. And then we're going 2.5 times as far as we usually do. Because tangent normally goes up 1 when you look at the comparison between the middle of the graph and halfway to the asymptote. This is a vertical change of 2.5 when it should be 1. So that's, we're getting stretched by 2.5. Last thing is a phase shift. Tangent normally starts, the middle is normally at 0. Where is our middle? Our middle's over here. Our middle got moved pi over 4 to the left. Or you could say our middle got moved pi over 4 to the right. They're both okay. Pi over 4 to the left, pi over 4 to the right. They're both correct. Let's say pi over 4 to the right. That way we have, well, it really doesn't matter. So what does that mean? That means c over b is pi over 4. We know that b equals 2. So that means that c divided by b, whoa, b is 2, is pi over 4. Cross multiply. That's going to give us 4c equals 2 pi. Divide both sides by 4. And you get c is pi over 2. We have all the pieces now. Let's just go. Y is equal to a, negative 2.5, times the tangent of b, which is 2, times x minus c, which is pi over 2, plus d, which is 2.5. This should be our answer. Let us unveil it. Is this what I graphed? Negative 2.5, good. Tangent of 2x minus pi over 2, good. Plus 2.5, good. We did it. All right, let me know if you have any questions on these ones. These ones especially with that stretching factor, can be pretty tough, okay?